Okay, in this short video, I'm going to look at converting numbers between different bases. Of all the concepts in our first unit, I think this one's given students the most pause. Not because it's necessarily difficult, but because it's something new that you may not have seen in elementary school. Um, the idea of these number systems of different bases, I think the easiest way to explain it is to think about place value. In our standard base 10 system, which we call the decimal system, each position or each place value is a power of 10. This is something that you've been familiar with probably for many years, since maybe grade 3 or 4. I've got my ones column, my tens column, my hundreds column, my thousands column, and so on. Each of those is a power of 10. Right? So I could say my thousands column is 10 to the power of 3, my hundreds column is 10 to the power of 2, my tens column is 10 to the power of 1, and then my ones column is really 10 to the power of 0. So when I change the base, all of my place values are also going to change. So we're going to start with the number 40, and I'm going to put this in different bases. So let's try base 6 first. Base 6 you might not be familiar with. It's not binary, it's not hexadecimal. In base 6, our place value columns, instead of being powers of 10, are going to be powers of 6. So I still always am going to have a ones column. That would be 6 to the power of 0. And I'm going to have 6 to the power of 1, 6 to the power of 2, and I could continue on. So if I needed, my next column would be the 2/16 column, because that would be 6 to the power of 3. So the number 40, how many 36s or 6s or 1s fit into 40? Well, I would have 1 in my 36 column. So there's 136. Then I still have 4 left over. So that's 0 6s, and it's 4 1s. And again, if you think about back to the way we learned to write numbers in expanded form in earlier grades, I've got 1 times 36, that's in my 36s column, plus I have 0 times 6, that's in my 6s column, plus I have 1 times 4, that's from my 1s column. So I could still write those numbers in expanded form. The largest symbol, the largest digit I would use in base 6 is a 5, because once I get to 6, I'd be moving into the next column, right? Because 6 in any of these columns would be a 1 in the next column. So just like the base 10 system, I use 10 symbols from 0 to 9. In the base 6 system, I use 6 symbols from 0 to 5. Let's put this same number into base 2. So base 2, binary, each place value represents a power of 2. So instead of each place value getting 10 times larger, it's going to get 2 times larger. And I don't need to go any further. I wouldn't have anything in the 64 column because my number from base 10 is only 40. So if I'm converting 40, it's going to be 132. And then I've still got 8 left over, so that's 0 16s and 1 8. And that is 40, so the other columns are going to be 0. And again, if I put this in expanded form, I would have 1 times 32, 0 times 16, 1 times 8, and then 0 times each of the rest. So I find it's going to be easier because we're used to base 10. We have 10 fingers. We've spent our whole life working in base 10. My recommendation is to always start from base 10 and then convert to the other bases. The last one is base 16. Base 16, hexadecimal, is again often computers like. So I can write my powers of 16. So 16 to the 0 is still 1. I still have a 1s column. 16 to the 1 is my 16s column, and then 16 squared is 256. Now, in base 16, because I can put the numbers 0 to 15 in each column, I need more symbols. So once I get past 9, I'm going to start using letters A, B, C, D, E, F to represent 10 through 15. And we'll see if we need that. Don't have any 256s in 40, but I have 2 16s. Right? 3 16s would be too much, but 2 16s is 32. And then I have 8 1s. So 28 in hexadecimal is equivalent to 40 in base 10. So that's my recommendation for how to convert between numbers of different bases, is to again think about place value. Each position represents an exponent of whatever our base is. So if you think about this number in binary, again, I think it makes sense to write our place values above the numbers. I know I'm running out of space a little bit. So in binary, I've got my powers of 2 as my columns. I know the camera is extremely laggy today. It's stuck in my hand. I'm kind of waiting for my hand to disappear. I may have to reshoot some of this video. But I've got, you can see each column either a 1 or a 0. So if I'm converting this back to base 10, I think it's easiest to work in decimal. I've got 1 times 32 is 32, plus 1 times 16, so now I'm up to 48. 0 times 8 is nothing, plus 1 times 4 is 52, plus 1 times 2 is 54. So 110, 110 in binary, 132, 116, 14, and 12 is going to add up to 54. Once I have the number in base 10, then I think it's easier. Again, we can put it into base 6. Those are my powers of 6. How many 36s fit into 54? Well, that's 1. I have 18 left over. From 36 to 54, the difference is 18, so that's 3 6s. 3 times 6 is 18, and that is 54. So I can just put a 0 in the 1s column. So if you see the number 130 in base 6, that also represents what we call 54 in base 10. And then same thing in hexadecimal. There's 3 16s in 54. 3 16s make 48. And then there would be 6 ones to get up to 54. So the number 54 in hexadecimal, we would write as 36. So it's the same quantity. If we saw a picture of ducks, it would be the same quantity of ducks in each of these systems. It's just different ways to write it depending on our place value system. We'll just do a couple more because I think it's helpful to have some examples. Let's go in different order. So I'm starting with 15 in base 10. In hexadecimal, well, I would put nothing in the 16 column because there are no 16s. Now, how do I write 15 in hexadecimal? We want to write it with one symbol. We can only fit one digit in each place value column. Well, if 9 is the biggest number, then 10 is going to be A, 11 is going to be B, 12 will be C, 13 D, 14 E, and then 15 would be F. So the number F in hexadecimal is equivalent to 15. So if you see an F in any column, that's representing 15 of whatever place value that is. In base 6, I'm only going to need to use 2 digits because I don't need to use my 36's column. The number is less than 36. In base 6, if you think about it, a 2-digit number is always going to be less than 36. So how many 6's fit into 15? Well, it's 2, and there are 3 1s. So again, if you think about that in expanded form, 2 times 6 is 12, plus 3 times 1, and I get up to 15. In binary, I'm going to need up to my 8's column. This is going to be a 4-digit number. I don't need my 16's column because 16 is bigger than 15. So each place value represents a power of 2, so I can fit in 1 8, 1 4, 1 2, and 1 1. And if I expanded that out of 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1. So the number 1 1 1 1 in binary, it actually takes 4 digits just to write the number 15. The last one is we're going to convert from base 6. It's probably new. We haven't done too much. Remember that 3 is the 1's column. And then that 2 is my 6th column, my 6th place. And again, I think it's easiest to always convert to or from base 10 and then think about the other bases. So if I've got 2 6's, that makes 12, and 3 1's, that makes 15. Whoops, I guess I kind of made this quickly. It looks like it's the same example again. But the idea is, whether I'm converting to or from a different base, I start by thinking about place value. So as we've grown up in math, because humans have 10 fingers, we've always thought about 1, 10s, and 100s. But there's no reason why that's the default. And math would work almost the same way if I used different bases. So each place value would represent something different. So the numbers would look different when we write them. We use different symbols, different amounts of digits. But any operations or anything like that would just work the same way. So that's a quick video on how to convert between bases. This will work with any base. Any base between 2 and 10, we can use just our normal symbols. If we're going beyond base 10, we would need additional symbols because I would need more digits in each place value column. Okay, that's all for now. You can let me know with a comment or an email if you have any questions. Thanks for watching.